Good morning. Today I will be talking to you about the physics of tennis. We will go over Newton's laws as well as kinetic energy. Before we begin, here's a quick video. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how does that relate to tennis? A tennis ball would not move unless a force acts on it, so the ball remains at rest. A player picks it up, throws it up in the air, and hits it with a racket. The ball will stay in the air, being hit from one side of the court to the other, until someone scores. And then the ball slowly comes to a stop due to gravity and friction. The forces of gravity, friction, air resistance, and the force of the rackets. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. But what does that have to do with physics? When you hit a tennis ball with a tennis racket, you exert a force on the ball. With Newton's second law, we can apply the equation F equals ma, force equals mass times acceleration. Since the weight of the ball does not change, the force of the ball directly affects the acceleration. So here I did calculations. I said that the time from a tennis ball of one serve the time it takes for one serve of a tennis ball is equivalent to 9.97 seconds, and the velocity would be 40 meters per second. So I did final velocity equals initial velocity plus acceleration times time. When I did that, I got 41 meters per second squared for the acceleration, and then I was trying to find the force, so I found the standard mass, which was 0.056 kilograms, and I used that acceleration that I found, multiplied them together, and got 2.9 newtons. Here's another video that shows a tennis ball before, during, and after a collision. Newton's third law states that with every action there is an opposite and equal reaction. It interacts with the tennis ball throughout the whole game. As a person is standing on the court waiting for the next serve, they are exerting a force on the court/ground. The court floor is pushing an opposite and equal force. This is why your body remains in the same place until you move. Kinetic energy in tennis. Kinetic energy is defined as the energy of motion. The amount of kinetic energy an object has depends on their mass and velocity. So the formula is 1/2 mv squared. An average male serve is 40 meters, 40 meters per second. The mass of the tennis ball is 0.056 kilograms. So when you put that in that equation, you get 45 joules. And that's all I have. Thanks for watching.